Okay, students, just I started a revision of the concept a power x equal to n. Then x is called n to the base a, condition a greater than 0, n greater than 0, and a not equal to 1. Leave it none. So just now I want to write properties. Okay, first what is the characteristic mantissa? Positive decimal part of x is called characteristic mantissa, and remaining integral part is called its characteristic. Okay. Now properties, first one, logarithm of 1 to any base. Any base means conditional base should be greater than 0, not equal to 1, equal to 0. Second one, logarithm of a number to same base equal to 1. A number to same base, again conditional, a should be greater than 0, a not equal to 1. Okay, third one, logarithm of m into n to the base a equal to log m base a plus log n base a. This is actually important law. You can call this actually law number 1. Okay, Nana? Same m and n are positive real numbers, a positive real number not equal to 1. Okay. Fourth one, logarithm of m by n to the base a equal to log m base a minus log n base a. This is called logarithm number 2. Again, m and n are positive real numbers not equal to 1. And n is also positive, means no need to say again n is not equal to 0, and a is greater than 0 and a not equal to 1. So this is fifth one, logarithm of m power n to the base a is nothing but n into logarithm of n to the base a. This is law number 3. Okay, after law number 3 you have the concept of change the base concept. Change the base means logarithm of a to the base b can be written as log a base some x into log x base b. Log a base b, a should be greater than 0, b should be greater than 0, b not equal to 1. Okay, this can be written as log a base a new base x into log x to the older base b. So you can extend this law also. Log a base b equal to log a base x into log y base z into, x base z into log z base b, like that you can extend. So condition x, y all should satisfy the condition of logarithms. Okay, this is called change the base concept. I can say this is 6. Extension no need to mention. 7, log a base b equal to 1 by log b base a, also conditional. A and b should be greater than 0, b not equal to 1. So here a also not equal to 1, that is important thing. Logarithm of m power n to the base x power y, important. So this n by y into logarithm of m base x, n by y into log m base x, provided all should be satisfied the definition of logarithms. Okay, this actually I can say law number 4. Okay, important, 9th one, very very important. Okay, then a power log x base a equal to x. If these two are same, the value equal to x. Proof easy only, that's not big problem, but important property, because this is not logarithmic class, na? Logarithm inequalities. 10th one, a power log b base c equal to b power log a base c. We can interchange these two. That is last 10th one. Yeah, logarithm of x to base a. Your x should be positive real number, your a should be positive real number, a not equal to 1. Okay, here x is called input. What is the domain of the function? Means what is x? For what values of x? Logarithm is defined, that is called domain. So your x should be positive real number. I can write open 0 to infinity. What is your a? Greater than 0, not equal to 1. So after giving some values of x, some log 1 base a means 0, log a base a means 1. So your output is taken as y. Now what is y? Your output, that is all real numbers. Y belongs to all real numbers. So this is called domain and this is called range. Okay, now I want to draw the graph of this function. Y is equal log x base a. Okay, listen here. Draw the graph of y equal to x plus 1. Easy. The value of y is depend upon the value of x. X changes, y will change. If x is 1, y is 2. X is 0, y is 1. X is minus 1, y is 0. every ordered pair followed by dot on the coordinate plane. Just identify those coordinates, those dots on the coordinate plane. 0 comma 1 here, 0 comma 1. So minus 1 comma 0 here, minus 1 comma 0, and next one 1 comma 2, like that, 1 comma somewhere here. Okay, taking all the solutions, x is any real number, y is any real number. No, that's why we get infinitely many ordered pairs. Plot all those ordered pairs on the coordinate plane. So we'll get like this. So all the points are taken. So what we will get, Nana? You get a straight line. This is the graph of y equal x plus 1 on the coordinate plane. Okay, so two unknowns, x, y is dependent upon x changes, y will change. So what is the meaning of here? If two unknowns are there, then you can draw its graph on the coordinate plane. If three unknowns are given, you can draw the coordinate plane. So now I can say that y is equal x plus 1. This is the graph. We can say that y equal x plus 1, representing a straight line on the coordinate plane, which intersecting the x-axis at minus 1 comma 0 and y-axis at 0 comma 1, and so on, so on, so on. And something you don't want now. Just I want to explain what is the meaning of graph of a function. Y equal x plus 1 given, you know how to draw the graph. Similarly, y is equal x square given, you can draw the graph. Y is equal x cube plus 1, you can draw the graph. Now my graph is y is equal logarithm of x to the base a. So now I want to draw the graph of log x base a to the log x to the base a equal to y. Okay. So y is equal to log x to the base a. Here x is variable, y is variable, a is variable. We can't draw the graph of this function on coordinate plane because three variables are there. That's why I want to take a as a fixed value. Already you know that a value can be taken from 0 to infinity because a greater than 0 and not equal to 1. So I want to divide the y equal log x base a into two pieces. Y equal log x base a where a is from 0 to 1, and log y equal log x base a where a is greater than 1. Okay. First case. So y equal to log x base a where a is greater than 1. Second, I will take case from a is 0 to 1. Okay. So here now again a is variable, no? Greater than 1 means infinitely many values. Again three variables, we can't draw the graph. So I want to take a fixed value. Let a equal to some 2. Now I want to draw the graph of y equal to log x base 2. After that I will generalize what is the graph of log x base a. So the graph is log y equal to x base 2. So this is the relationship between x and y. Now we want to find the sum of the solutions of this equation. So two variables are there, means the solution is mean of ordered pairs only. So I want to write ordered pairs here, just here. X is 1, y is 0. X is 2, y is 1. Actually, you can take any x which is positive real number. You can take x equal 1.2, 1.3, 1.4 also. But finding y value is difficult for me. That's why I am choosing some specific x values like 1, 2, 4, 8 like that. So if x is 4, then y is 2 only, log 4 base 2. So x is taken as 8, y is equal to 3. Okay, if x is taken as 1 by 2, x is taken 1 by 2. So what happened, Nana? Logarithm of 1 by 2 base 2, that is equal to logarithm of 2 power minus base 2, that is minus 1. Okay, so if x is taken as here 1 by 4, then y will get minus 2. X is taken as 1 by 8, we get minus 3, so on. Means if x, you can take x any positive real number, you get y is any real number. Okay, now every solution is ordered pair. Already you know that every ordered pair gives a dot on the coordinate plane. So this is coordinate plane. Here 1, here 2, here 3, here 4, 6, 7, 8, here minus 1, minus 2, minus 3, 1, 2, 3, 4. Okay, this is our coordinate plane. Now I want to plot all these solutions on the coordinate plane. 1 comma 0, here 1 comma 0, 2 comma 1, 2 comma 1, 4 comma 2, 4 comma 2. Yeah, x is equal to 8, we got y equal to 3. X is taken as half means middle, y equal to here. So finally, if you take all the solutions, your graph will be like this. Okay. So finally, this is the graph of y equal log x base 2 graph. So y is equal log x base 2. Okay. Now we want the graph of log x base 3, for example. Actually, I want to generalize log x base a graph. Log x base 3. Log x base 3 means what? X is 1, y is 0. That graph also passes to this point only. Okay. X is 3, y is 1. X is 1 by 3, y is minus 1. X is 9, y equal to 2. Okay. 1 comma 0 here only. 3 comma 1, 3 comma 1 somewhere here. Next what nana? 3 comma 1 by some 9 comma 2, somewhere 9 comma 2. What happened? If you take all the values, you take all positive x, you get all y values, you get infinitely many ordered pairs, plot all those ordered pairs on the coordinate plane, your graph will be like this. Important thing is this line never touches the y-axis, but nearer to the y-axis. Okay, so second one is y is equal log x base 2, sorry x base 3. Okay, what happened on here? If base is increasing, the graph is somewhat nearer to the y-axis. Okay, so final conclusion, log x base 3 or log x base 2 or log x base 4 or log x base root 2 or whatever it may be, log x base a, if your a greater than 1, all the graphs will be in this form. All graphs, all are passing through 1 comma 0, all graphs. Okay, so final discussion, final conclusion. This is the graph of y equal log x base a greater than 1. In a greater than 1 cases, all the graphs of logarithmic function should be of this form. Now important conclusions. Okay, if x is equal 4, for example here, y is equal log x base 2, no, this one, first one. X is equal to 4, what is the corresponding y? 2 only. So graphically you want to conclude, if x is equal to 2, what is y? So at 4, we need to draw a line perpendicular to x-axis. Okay, that line intersect the graph somewhere. From that point you need to draw a line parallel to x-axis. That line will intersect the y-axis somewhere. For example, this line intersecting the y-axis at point 0 comma 2. Then 2 is taken as corresponding y value. Means if x is 4, y is 2. If x is taken as 5, we want to find corresponding y. Okay, if x is 5, we want to find corresponding y. At 5, draw line perpendicular to the x-axis. This line intersect the graph somewhere. From there, you need to draw line parallel to x-axis. So this is, for example, this is 0 comma k. Now I can say that if x is equal to 5, y equal to k. In this way, you can find x values and corresponding y values on the coordinate plane or on the graph. By using graph only, you can find. Okay, observe here. Now I want to remove this portion. Now I am generalizing. Okay, for this x value, I want to find corresponding y value. For this x value, you need to draw perpendicular to x-axis, intersect the graph at this point, you need to draw parallel to x-axis. This is corresponding y, means 0 comma something is there, that's something corresponding y value. For this x, corresponding y here. 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 Important observation. Take any values of x from 0 to 1. X is from 0 to 1. Your y values are negative. All y values are negative. So, y belongs to minus infinity to 0. For these x values, your y value is negative. Means what is conclusion, Anna? Conclusion. If x belongs to 0 to 1, then y is negative. Important note. If x is 2, y is here. X is 1, y equal to 0. X is equal to 1, then y equal to 0. If x is greater than 1, y is positive. See, for this x, y here. For this x, y here. Y positive. Means I won't write that. x belongs to 1 to infinity, then y is positive. Important. Through graph only you can get the conclusions. Okay. So finally, so this is the graph of log x base a. See, observe here. For this x, corresponding with here. For this x, corresponding with here. What is observation? For these x values, your corresponding y values are negative. For these x values, your corresponding y values are positive. Okay, students. Now I am concluding the graph of y equal log x base a under condition a greater than 1. The graph is in the shape. Here 1 comma 0. Yeah, this is a graph of log y base a. Log x base a equal to 1. Important conclusions. First one, x belongs to open 0 to open 1, then y is negative. Second one, x belongs to 1 to infinity, then y is positive. Third is important. Observe all of you now. Important conclusion. Say this is x1. Corresponding y value is this. Say y1. This is x2. Its corresponding y value is here y2. Important. Observe here. So what is y1 nanane? Y1 means f of x1 only. Y2 means what? F of x2 only. Observation here in the number line x2 greater than x1. X2 greater than x1. What is the relationship between y1 and y2 nana? Y2 greater than y1. Means if x2 greater than x1, you are getting x2 greater than x1. What you are getting? Y2 greater than y1. Okay. So y1 is nothing but f of x1 means what? Logarithm of x1 only. Y2 means what nana? Logarithm of x2 only. So if y2 greater than y1, y2 greater than y1. So what is the relation with these two nana? Log of x2 base. Log x2 is greater than log x1 only. So I can say that log x2 here a base is greater than log x1 base a. Important. Means what happened? Log x2 base a is greater than log x1 base a. Automatically what you can say? x2 is greater than x1. Okay. y2 is greater than y1. What is the meaning of that? Log x2 base a greater than log x1 base a. What is the relation between x1 and x2 nana here? x2 greater than x1 only. So means what is x2 greater than x1? If x1 greater, if x2 greater than x1, what is logarithm of x1 and logarithm of x2? We want to find the relationship between logarithm of x2 and logarithm of x1 with the base a which is greater than 1. So what happened? This gives logarithm of x2 is greater than logarithm of x1 to the base a. Important note. If x2 greater than x1, logarithm of this function still greater than logarithm of this function. Under condition your a should be greater than 1. If a is greater than 1, if x2 greater than x1, automatically log of x2 is greater than log of x1. Observe here. x2 greater than x1. y2 greater than y1. Your input in your inputs x2 greater than x1. In output also y2 greater than y1. Means what? X is increasing. Automatically y also increasing. X is increasing. Y also increasing. Means this is called increasing function. Log x base a under condition a greater than 1. It is increasing function. That I will write here. This is third one. If x2 greater than x1, double implies log of x2 base a greater than log x1 base a. Important. Sometimes you can say that x2 is greater than x1. Applying log on the other side. Inequality would alter. Okay, applying is not correct, but the result is just like that. Okay, fourth one. Logarithm of x to the base a is a increasing function. Important, increasing function for a greater than 1. A greater than increasing function. For this x, this is y. For this x, this is y. X increased, y also increased. Increasing function. So that's why in your graph you need to write graph. arrows like this, increasing graph. So this is the graph of log x base a under condition a greater than 1. Okay students, next case, yeah, case 2, base is from 0 to 1. Okay, so now I want to draw the graph of logarithm of x to the base a, where a is lies between 0 to 1. Again 0 to 1 there are infinitely many real numbers. So variable, problem becomes difficult for us. Or you can't draw the graph on the coordinate plane. That's why I want to take a fixed value of a in between 0 to 1. I will take a equal to 0.1 for my convenience. A is taken as 0.1. Now I want to draw the graph of y is equal log x to the base 0.1. Y is equal logarithm of x base 0.1. Okay. Now we need to prepare the solutions for this. X is 1. Convenient x values I am taking. Convenient x values only I am choosing here. That is important. So x is 1, y is 0. Yeah, x is 10. Observe, x is 10. So what is this actually? Logarithm of x to the base 1 by 10, 10 power minus 1 actually. So here 1, that is nothing but 1 by minus 1 into log x base 10 minus log x base 10. Actually this is a minus log x base 10, or you can write minus log x base 10 also you can write. That is not a big problem. X is taken as 10 base 10, 1 minus 1 will get. X is taken 100, here 2 minus 2 will get. Understood? X is taken as 0.01, yes, we will get 1. Here only you can say that, no, log 0.1 base 0.1. You take x is 0.01, 10 power minus 2, 2 will get 2. So these are some solutions. Now I want to plot all these on coordinate plane. Important Nana, observe here. This is y axis, this is x axis. Yeah, 1, 2, 3, minus 1, 1, 2, 3, minus 1. Okay. X is 1, y is 0 here. X is 10, y is minus 1. X is somewhere 10 minus 1 here somewhere. X is 100, y is minus 2 somewhere. X is 0.1, x is 0.1 here, 0.1. X 0.001, nearer to this. Whatever 2. So means if you take all x values which are positive real numbers, then your graph will be like this. Understood? Previous graph is increasing graph. No, this is the graph for logarithmic function for the values of base from 0 to 1. Just like this is the graph of log x base 0.1 only. Take any value from 0 to 1. The graph shape will be like this. All the graph will passes through 1, 0, 0 only. That is not a big problem. So finally, what I can say that actually this graph is this is a graph for y equal logarithm of x to the base 0.1. Instead of a, you can take any value from 0 to 1. Your graph will be like this. All will passes through 1, 0. Now you can conclude that this is the graph of log y base a, where a is lies between 0 to 1. Now conclusions. For x2, the corresponding y is minus 1. For x is this, your corresponding y is here. For this x, your corresponding y here. For this x, your corresponding y here. Means if x is taken from 0 to 1, y positive. Conclusion. If x belongs to 0 to 1, then y positive. Important. So 1 to infinity, if x is equal belongs to 1 to infinity, then y is negative. Negative for all these x values, y negative only. X is equal to 1, y equal to 0. That is not a big problem. So these are important. No need to by any concepts. No need to by any formulae. Please, just by using these two graphs, you can solve all inequality problems. Important. Okay, finally what happened? This is x1. Your corresponding y is here. I can say y1. Understood? y1 means log of x1. Understood? So y1 means log of f of x1, that is y is equal log of x1. Take x2 here. See, x2 value greater than x1, no, here. Take x2. The corresponding values here. This is y2. Observe here. x2 greater than x1, but y2 less than y1. Means x increased, y decreased. X is here, y is here. X is here, y is here. X changed from x1 to x2, increased. Then what happened to y? Y decreased. Y changed from y1 to y2. X is increases now from x1 to x2. Automatically what happened to y? No, decreased y1 to y2. Means x is increasing, y is decreasing. In previous one, x is increasing, y also increasing. X is increasing, y is increasing. That's why we call increasing function, that one. So this is decreasing function. x1 is less than x2. Then what happened, Nana? The relation between y1 and y2, y1 greater than y2. See, unequal altered. In previous one, what happened? In previous one, x1 less than x2, giving y1 less than y2. x1 less than x2. Then what is the relation between y1 and y2? y1 less than y2 in previous one. Here x1, here x2, here y1, y2. Observe. x2 greater than x1, y2 greater than y1. So y1 means what? Log of f of x1. Sorry, log of x1, log of x2. Okay, here what happened? x1 less than x2, then y1 greater than y1. Unequal altered here. Inequality. That's it. No change in inequality. Here unequal altered. Understood? So I can write like this: x1 less than x2. Then y1 means what, Nana? Logarithm of x1 is greater than logarithm of x2. Sometimes you can say that if x1 less than x2, logarithm is applied, inequality altered. When your base should be lies between 0 to 1, inequality will alter. If a greater than b, Nana, log a log b given. What is the relation between them? If a greater than b, log a log b relation is greater or lesser depend upon its base. So for example, base is k. So greater or lesser depend upon k. If your k is greater than 1, then under this condition I can say greater only. If k lies between 0 to 1, I can say inequality will alter. This is important concept. For to explain this concept, I used graph. Students, final conclusion for graph of logarithmic functions. Y is equal logarithm of x to the base a is given. We want to draw its graph. Two cases will arise. Case 1, a greater than 1. Case 2, 0 less than a less than 1. Okay. Case 1, this is the graph. 1, 0. Increasing function. Case 2, decreasing function. Okay, increasing, decreasing. We can solve the problems logarithmic inequalities by using the concept of graph of logarithm only. Here, for these x values, y negative. For these x values, y positive. X is less than x2, just like applying log another side the base a, log x base, log x1 base a still less than log x2 base a. Here observe here, for these x values y positive, for these x values y negative. x1 lesser than x2, double implies log of x1 base a is greater than log of x2 base a. Means x1 is less than x2, applying log another the base a, inequality will alter if your base is from 0 to 1. Okay, observe here. Log some x base 3 greater than 1 given. We want to find x value. Observe here. Both sides I want logarithm. Both sides I want logarithm to apply this concept. So logarithm of x to the base 3 greater than 1 means I can write log 3 base 3, 4 base 4, 5 base 4, anything I can write. But I want base 3 only. That's why instead of 1 I am writing log 3 base 3. Okay. Just like this is the form of log x1 base a greater than log x2 base a. x1 is greater than x2 or x1 is less than x2 is depend upon a value. Okay, if a is greater than 1, unequal won't alter. Directly you can say x1 greater than x2. If a is from 0 to 1, I can say that x1 less than x2. But what is a here? 3 greater than 1. Directly I can say x greater than 3. Understood? Log x base 3 greater than 1, then find x value. So I can say that x is greater than 3. Understood? This concept is very, very important. Please students, sincere advice for you. Don't by heart formulae, one thing. But don't conclude properties by using or by taking examples. Okay, try to learn the concepts. By using concepts, you can solve so many problems. Okay, please don't conclude properties by using or by taking examples. See, here I explained clearly by using a concept only.